So let's take a look. Sophia, you're good to go. So guys, let's take a look at example number 1 here. All right? A lot of you guys did great on this where you distributed, okay? And then we subtracted our 6x over on this side. 2x plus 2 is greater than negative 14. Subtracted 2, so our 2x was greater than negative 16. Sorry about that. We divide both sides by 2, and we have x is greater than negative 8. So guys, our final answer was negative 8. Remember, a negative divided by a positive is a negative. Now guys, if you were going to graph this on a number line, I would always put my negative 8 right in the middle, and I would think, okay, open circle, because it's just a greater than, right? And then if we're going to the right, if it's greater than, you're always going to the right, okay? One way to help is, guys, a less than symbol looks like an L. Like, see, if you hold up your left hand, that's the less than symbol. And so you go to the left. The greater than, you go to the right. So then I would probably do my other little numbers here. So all of my values are going to be greater than negative 8. So one value that makes it true is what? What is one value that is true that we could put in this inequality after looking at our number line? Negative 7, right? Or negative 6, or negative 5, or 100, or 3,000, right? Okay. So anything that's bigger than negative 8 is going to make it true. So I'm going to say negative 5. Y'all good with that? But you could put 100, you could put 0, you could put 5, okay, your favorite number, okay? One value that is false, can y'all give me one value that's false? Negative 9, or negative 10, or negative 11, because see how it's not covered. Or negative 3,000, right? That is not greater than negative 8. So I'm going to do negative 9. Thank y'all so much. So I just want you guys to remember like the meaning of this right here. It's anything bigger than negative 8. All right. For example number 2 here, we had 3 parentheses p minus 3 minus 5p is less than or equal to negative p minus 6. So guys, when you check this out, we distributed, then we combined our terms. We didn't have to combine any terms in the first one. We combined our like terms on the left side of the equation. The right side was already good. Then we combined our variables. Now, I will say, guys, when solving inequalities, it is very helpful to always move to the left side. Because if you move to the right side, then you're going to have to deal with flipping the inequality at the end. And sometimes that gets... So I guess you're either going to flip it when you divide or flip it at the end. But I like to move my inequalities always to the left. So, or my variables. So I added my p here and added a p. So I had a negative 1p minus 9 is less than or equal to negative 6. I added my 9 to both sides. And then I had to divide by a negative 1. And when I did that, guys, what did we have to do? Flip the sign. So the correct answer is p is greater than or equal to negative 3. So if we were going to graph this, then I would say, okay, negative 3. But since it's greater than or equal to, I'm going to draw a little closed-in circle. And it's greater than, so it's going to move off to the right. So now I'm going to fill in the rest of my number line here. Negative 2, negative 1, 0, negative 4, negative 5, negative 6. I want you guys to write down or just tell me value that is true, one value that's true, and one value that is false. Okay? I want you to tell me one value that's true and one value that's false. All right? Parker, what's one value that's true for this problem? What is greater than or equal to negative 3? Negative 2. Also, one thing I want you guys, 0. Also, negative 3, right? Would that still be true? Yes. If we had said negative 8 up here, that would have been false because it's just greater than. But negative 3, that could also be true. I also heard people say 0. That's wonderful. Okay, Sophia C., what is one value that makes it false? Negative 4. Perfect. It's kind of nice to go right up next to it if you guys want to be creative and say, negative 5,216. That's fine too. Okay, one value that makes it false. All right, last one, example 3. This one was a little tricky, okay, because of this negative sign. What I saw a lot of people do was they distributed this 36. So then we were dealing with really big numbers like 324 and blah, blah, and all that stuff, okay? So we were dealing with really, really big numbers that way. But guys, when we have minus 9 minus 2m, or minus parentheses 9 minus 2m, that minus sign is what gets distributed, not the 36, just the coefficient. So that's why I like to write that little invisible coefficient of 1 so we don't lose it. Okay? So we distributed that negative 1 over here on the left. We distributed our 4 over here on the right. And we got 36 minus 9 plus 2m. Because a negative times a negative is a positive. Then 7m plus 4m minus 9. Okay? Then we look here, and we put these guys together, 36 minus 9. We put those guys together to get 27 plus 2m. We combine these terms to get 11m minus 36. I went ahead and subtracted my m over to the left. So I got 27 minus 9m is greater than negative 36. Then I subtracted 27. And finally, I divided by negative 9. Now, guys, when you divide by that negative 9, you have to flip the sign. So my final answer, negative 63 divided by negative 9, was m is less than 7. So I'd go over here and I'd write 7. And because it's just less than, it's an open circle, we go to the left here. And a value that makes this true, and so I'm going to say 6, 5, 4, 8, 9, 10. Okay, what is one value that makes it true? What's one value that makes it true? Anybody? 5. Yes, because it's less than 7. What is one value that makes it false? What is it? 1,000. That definitely makes it false. Also, 7 is false. Because 7 is not less than 7, right? 7 is equal to 7. So 7 would be false. Okay? There's a bunch of things that make these true and a bunch of things that make these false. All right. So guys, real quick, this last page I want to take you guys through is I want to take you guys through some special cases. All right? So I want to take you guys through some special cases. So, guys, sometimes something might happen with your variables, okay? So, check it out. Now, we're going to do a little bit more of this next time, but I just want you guys to see what happens when there's some special cases. Okay. So, guys, there are times where you will solve an equation or an inequality, and you might get a false, you might get no solution or infinite solution. Okay? So there are times where there are no solutions. Okay? I'm going to kind of do it like this, right down the middle. There are also times where there's infinite solutions. Okay? And we're going to talk about, so these are special cases, all right? Sometimes there's no solution. Sometimes there's infinite solutions. All right? And this happens when something funky happens with our variables. Okay? So let's take a look at this. If we have negative 4 times 2x plus 1 is equal to negative 8x minus 2. Well, guys, the first thing we got to do is what? distribute. Okay? So we do negative 4 times 2x gets us negative 8x. Negative 4 times positive 1 gets us negative 4. And that is equal to negative 8x minus 2. All right. So guys, check this out. Next, we need to combine like terms. Well, is there anything to combine on the left and anything to combine on the right? No. So then our next step is to move our variable terms. So guys, I'm going to add 8x to cancel this out and bring it over to the left. But what's going to happen? Okay, both of our variables cancel out. So that just became 0x, didn't it? Or 0. So those cancel out, and we're left with negative 4. These cancel out, and we're left with negative 2. Guys, is this a true statement? Is negative 4 equal to negative 2? No. So guys, this is a false statement. So this means that there is no solution to that. So guys, if your variables cancel and you get a false statement, there's no solution. Now, remember, it's okay for your constants to cancel because you can do 0 divided by a number. It's okay for your if your constants all cancel, your answer is probably going to be 0. But if your variables cancel, you have to see, is it a true or false statement? Okay? So because it's a false statement, there is no solution to this problem. All right. So now I want to show you guys what happens when we have what happens when it looks a little bit different. Let's see here. We have negative 5 minus 9x equals 3 times 1 minus 3x minus 8. Okay? So the first thing we're going to do is we're going to distribute. So 3 times 1 is 3. 3 times negative 3x is negative 9x. And then we still have our minus 8. The left side of our equation didn't change, so I'm just going to bring it down because we didn't have to distribute. Now we need to combine like terms. So the left side, those terms are already all individual, but we need to combine our like terms here. So 3 minus 8 is going to give us negative 5 minus 9x. Ooh, what do you notice about this equation? Both sides are the exact same. Guys, up here, were both sides the exact same? No. So this gives you a good hint right now that it's going to be a little different. So now, guys, let's move those variables. If we add 9x to both sides, we get negative 5 is equal to negative 5. Interesting. Is negative 5 equal to negative 5? Yes. This is a true statement. So this means our answer, we have infinite solutions. Okay? Another way to write that is all real numbers. Okay? Now when you write it as all real numbers, kind of the fancy math way to do that is with this little double R. Okay, it's like a fancy little R. Have you guys ever seen that before? Where well, it's like a curly QR when you have it on, like when you type it out in like the math equation, it's like a really fancy R. But this right here, I do a double lined R. That means all real numbers. So that means every real number you can think of. The reason we have to distinguish is because there are such things as imaginary numbers, if you didn't know that. Okay? You don't really do those until Algebra 2, but there are such things as imaginary numbers. So we have to distinguish that they're all real numbers. I know mathematicians got bored with just, regular math, so they wanted to make up math for their imaginary friends. Okay, so guys, sometimes there's infinite solutions, sometimes there's no solution. I want you guys to do 2 little examples, and you guys can decide if they're infinite or if they are no solution, okay? So this first one is going to be 3 parentheses 2x plus 2 minus 3x equals 6 plus 3x. And then your second example is going to be 3x minus 13 equals 7 times x plus 2 minus 4 x minus 7. All right, guys? So I want y'all to do those. And I want you guys to determine if they are real numbers or if they are, or if it's all real numbers, infinite solutions, or if it is simply no solution, okay? These are special cases, remember? So every now and then, if your variables cancel out, you've got to pay attention. Mm-hmm. All right, guys. So for example 1, what did you guys, are you guys still working on it? I'll let y'all work. What did we get for example 1 there? It is a true statement. Okay, when we do it all right there, we get down to this last little bit. So this right here is true. So what does that mean?
All real numbers.
It is all real numbers. Okay? You can do the little fancy R, or you could have also written, infinite solutions. That means, guys, what that means is no matter what number I plug in, it's going to work. If I plugged in a 5, then both sides would be equal to, 21. Okay? If I plugged in a 0, both sides would be equal to 6. If I plugged in a 1, both sides would be equal to 9. If I plugged in a whatever, both sides are going to be equal to each other. It doesn't matter what number you pick. If I plugged in 1.26847, both sides would be equal to each other. Okay, guys? So any number you put in would be a solution in this case. All right. For example 2, was this a true statement? No, that is a big old false statement. So the correct answer is no solutions. This means no matter what you plug in, it's not going to work. Okay? This exact same thing can also apply to inequalities. All right? The difference with inequalities is sometimes you might get something like negative 13 is less than 42. Is that true? Yeah, so then it's a true statement, okay? So with inequalities, you have to pay attention to that inequality sign to see if it is a true or false statement. All right, guys, so you can have special cases with your equations and special cases with your inequalities. So, guys, right now, we have just under 20 minutes left in class, so I want you guys to go ahead and get started on your homework. All right.